Good morning, everybody. Once again, your friend Dr. Salim is here with you guys. Let's do a few more questions, like 20 questions for the SPI review questions. Let me share the screen with you guys and let's start it. Let's see how we can do this. Okay, so now the question is, it says commonly how many cycles are there in a pulse from the pulse wave ultrasound? Like normally or commonly, how many cycles are there when we do imaging, when we do taking pictures and ultrasound or sonography? So is it 2 to 3, 5 to 10, too many, like uncountable, I can say, or there are no cycles in the imaging involved? Or depend on the tissue we scan. So it's just depend on the tissues and then the transducer will send how much cycles. So what do you think? Which one is the correct answer? Exactly, you're right. It is commonly either each pulse for the imaging, it's made of 2 cycles or either 3 cycles. If a pulse is made of 3 cycles, the whole pulses will be just 2 cycles. If one pulse is made of 3 cycles, the whole pulses will be made of 3 cycles. So either they are 2 or 3. All right, next question. Let's do this question, easy question. Now, the following diagram is related to which modality? Means which is it? Like look to the options. Is it a continuous wave ultrasound? We see the pulses like this in continuous wave ultrasound. Do we see them in a pulse wave ultrasound? Do we see them like in a M mode or motion mode or none of the above? What do you think? Exactly. Correct answer is a pulse wave ultrasound because there is a pulse and there is a listening. So there is a gap between each pulses. Correct. Let's do the next question. Now, the question is, which of the following is related to pulse wave ultrasound? Choose the best option. Now, look at the options. Range resolution, range specificity, freedom from range ambiguity, or all of the above. Which of these options suitable or more perfect for the pulse wave ultrasound? Yes, 3 of the answers. So all of the above is the correct answer. Absolutely correct. Next question. Let's do this question. Pulse repetition period is defined as below. Like what is the definition for pulse repetition period or PRP? Is it time measurement of a complete cycle? Is it a distance measurement of a complete cycle? Or we can say, what complete pulse? Is it time measurement from beginning of one pulse to the beginning of next pulse? D, is it the time measurement from the beginning of a pulse to the end of that pulse? Or D, distance measurement from the beginning of to the pulse to the beginning of the next pulse? So which one do you think is the correct answer? Exactly correct. Your answer is C. The time measurement from beginning of one pulse to the beginning of next pulse. So that will be PRP or pulse repetition period. Good job. Let's do the next question. Okay. It says, if pulse repetition frequency of a system is set to 10 kilohertz, so the PRF is 10 kilohertz, what would be the pulse repetition period, PRP? What do you think, how we calculate that? So the answers are 0.1 millisecond, 1.0 millisecond, 10 milliseconds, 10 seconds, or 0.1 microsecond. So if you remember the formula is PRP is equal to 1 divided by PRF, and PRF is equal to 1 divided by PRP. So here we are looking for PRP, correct? So we have a PRF, so it means 1 over 10, and that will be 0.1. Now, why millisecond? Because the frequency was mentioned, the unit of the frequency was kilohertz. That's why the unit for the time will be millisecond. Good job, absolutely correct answer. Okay, next question. We have a pulse wave and measure the pulse duration to be 20 microsecond and the listening time to be measured it's 100 microsecond. Now calculate the PRP. You have a PD and you have a listening time LT. So how to calculate the PRP? What do you think? Which one is the correct answer? Is it 2000 microseconds, 80 microseconds, 120 microseconds, 50 microseconds? None of the above. What do you think? Which one is the correct answer? Exactly correct. 120 microsecond, because the PRP is the combination of PD plus, or we can say, or you can additional to that. So PD, pulse duration plus listening time. So one is 20, the other one is 100. So that's 120. Correct answer. Let's do this one. Numbers of pulses that occur in 1 second is called what? So it's a definition, but it's good for which of the following, like which option really explain the above definition? Frequency, PRF, pulse repetition frequency, PRP, pulse repetition period, and duty factor, or pulse duration. What do you think, which one is the correct answer? Carefully. Exactly. This is PRF, pulse repetition frequency. So they are the number of pulses which occur in 1 second. And then, of course, the unit will be hertz after that. Correct. Okay, now, next question. If the pulse repetition frequency, or PRF, of a system was measured to be 10 megahertz, sorry, what would be the pulse repetition period for this system? So what do you think? If your PRF is 10 megahertz, just we had earlier the formula. The formula was, if you remember, just I mentioned it earlier, that if you have a PRF, to calculate the PRP, so 1 over PRP. If you are looking for PRP, but you have the PRF, then 1 over PRF. Here we have the PRF, and that is 10 megahertz, sorry. So now 1 over 10, that will become 0.1, and the megahertz is, because it's a megahertz, for the time PRP, we're looking for the PRP, the period is a time, the unit for after megahertz will be the microsecond. So that is the correct answer. Now, let's do the next question. Now, if there were 10 pulses that occur in 1 second, calculate the pulse repetition frequency for this system or this machine. What do you think? Is it 10 hertz, 10 kilohertz, 10 megahertz, all of the above? None of the above. A very simple question. Exactly, is the correct answer, 10 hertz, because one of the definition of the frequency is the number of pulses that occur in 1 second. But of course, because it's a 1 second, it's a second, so the unit will be hertz. Correct. Let's do the next one. Okay, so this question is asking for, we have a pulse ultrasound wave, and each pulse is made up of 2 cycles. Now, the time for 1 cycle measuring is 20 microseconds. What will be the pulse duration? So the options are 10 microseconds, 2 microseconds, 20 microseconds, 40 microseconds. Which one is the correct answer? What do you think? Exactly, 40 microseconds. Why? Because your pulse duration is the total time of 1 pulse we are looking for. So if 1 cycle, they tell you that the pulse is made of 2 cycles. 1 cycle took 20 microseconds. So there are 2 cycles. So one is 20, the other one is 20, that will be 40 microseconds. Correct answer. Okay, next question. We have a pulse ultrasound wave, and the pulse repetition period, or PRP, is 100 microseconds. And the listening time measure 80 microseconds. What will be the pulse duration? So the answers are 20 microseconds, 80 microseconds, 100 microseconds, or 80 microseconds. What do you think? Because now it's telling you that we have a pulse wave ultrasound and the pulse repetition period, PRP, from the beginning of the pulse to the beginning of the next pulse. So this is 100 microseconds. And only 80 microseconds is the listening time, LT. So remember, now we're looking for pulse duration. Itself, PRP is made of pulse duration and listening time. So if the whole PRP is 100 microseconds and only listening time is 80, so it means the remaining is 20 only, and that is the correct answer. So that will be the pulse duration, 20 microseconds. Correct. Next. We use a 6 megahertz transducer to scan a femoral artery, and the pulse ultrasound wave that this probe is producing has 3 cycles per pulse. Now, what would be the pulse duration? What do you think? Now, the answers are 18 microsecond, 0.5 microsecond, 9 microsecond, 3 microseconds, or 6 microsecond. What do you think? Which one is the correct answer? So your frequency is 6 megahertz. Correct, because the formula is number of cycles n divided by frequency or operating frequency. Now the number of cycles are 3. 3 divided by 6. I believe so. In the end, that will be 1 divided by 2, and the result will be 0.5 microsecond. Why microsecond? Because you can see it's a megahertz. That is the correct answer. Good job. Okay, let's do the next question. Now, what does duty factor indicate in ultrasound physics? It means, what is the definition of we can say duty factor? Actually, that's the question. It defines the pulse transmission time percentage. It defines pulse reception time in a percentage. It indicates numbers of pixels in a picture. It indicates the number of focuses in a picture, or none of the above. What do you think? Which one is the correct? Like, what is a duty factor? Actually, that's the question. Exactly, you're right. It will define the pulse transmission time in a percentage, because we have two phases of the sound. One, the sound go inside to the tissue, so that's the transmission phase, and the other one is reception. It's coming back, the reflection. So we are looking to how much time take to produce to go inside, and then how long it's like the machine, how much the time machine spend on sending the pulse, and how much the machine take time to listen to that. So actually here we're looking for how much time it take for the machine to spend on transmissions. So that is actually called duty factor. It's a specific formula it has for that to calculate it. So this is the correct answer. Correct. Okay, let's do the next question. What is the unit for duty factor? Like what unit are used for the duty factor? Is it millimeter, megahertz, percentage, microseconds, or hertz? Exactly, just we had it here and that above question. So it is the percentage. C is the correct answer, because it is actually you're looking for the PD divided PRP times 100, and that time hundreds will make it a percentage, and that is the correct answer. Good job. Okay, next question. Now, what is the normal or actual duty factor for the, like, what is a real duty factor for pulse wave ultrasound? Okay, let me make the question more clear. How much time in a real world it take for a pulse wave ultrasound, for imaging ultrasound, that it take duty factor, like how much time percentage it take for the machine to transmit the pulses, and how much time it take to listen back. So which one is the correct answer? Less than 1%, less than 1 microsecond, less than 1 megahertz, less than 1 millimeter, or less than 1 hertz? What do you think? Which one is the correct answer? Exactly, we're looking for percentage, so it's less than 1%. So let me explain a little bit. For the machine, when they send the pulses, it just take less than 1% of time the machine spend on sending the pulses, and their listening back is almost 99 or more than 99%. So we can say the maximum time the machine spent on the listening, on the coming back echoes. Machine listen too much. It just take a little, less than 1% time to send the pulses. So that is the correct answer. A was the correct answer, just keep in mind. All right, now next question. What is the normal duty factor for continuous wave ultrasound? Less than 1%, 100%, 100 microseconds, more than 1 megahertz, or more than 1 millimeter? What do you think? Just everything explained earlier. Exactly, you're right. It's 100% for the continuous wave ultrasound. Why? Because the reason is there are two crystal system and the continuous wave ultrasound. They are non-imaging modality, right? So one pulse, one crystal is completely continuously sending the pulses. The other one is continuously receiving the echoes or the reception. So it means they never have a break. There is no fast. They are just continuously sending. So that's why it's 100% on. So machine is on in a continuous wave ultrasound 100% all the time. They don't, because somebody else is listening. There's another crystal that's listening. This crystal's job is only to sending continuously. Correct. Next question. Now choose the correct formula for the duty factor calculation. Just I said that earlier, but let's see if you can figure out. Is it n times t, number of cycles in a pulse, times the period of one cycle? Is it PRP, pulse repetition period, plus PRF, pulse repetition frequency, times 100? Is it PRP divided by PD times 100? Is it PD divided by PRP times 100? Is it duty factor is PRF divided by PRP times 100? What do you think? Just I mentioned it earlier. Exactly, D is the correct answer. PD, pulse duration divided by pulse repetition period times 100. That is the correct answer. Good job. Okay, next question. Calculate duty factor for a transducer with 100, we can say PRP with a PRP of 100 microsecond and the pulse occurred and a 5 microsecond. Let's make this question a little more easier. If your PRP is 100 and your PD, pulse occurred, PD is 5 microsecond. Now, what do you think, which one is the correct answer? You have a formula here, correct? In the D, there's a formula. So PD, that's 5 divided by the PRP, which is 100, and then times 100. So I believe D is the correct answer. That's a 5%, right? So that is correct. Okay, let's do this question. The time which takes place to complete one cycle in ultrasound wave is called what? Like, what does that timing call? It just complete one cycle in a pulse, just one cycle with a compression and refraction. What do you think? Which one? Is it pulse duration? Is it a period or time? Is it a pulse repetition period or PRP? Is it a PRF, pulse repetition frequency, or is it a listening time? Yes, it's a period or time. That is for one cycle, only one cycle to happen at that time. Pulse duration is the whole pulse. Maybe there are 3-4 cycles in one pulse. So that's a difference. Okay. And last question, not least. Okay. If we use a 5 megahertz transducer to scan abdominal aorta, what would be the period of waveform? What do you think? If you're using a 5 megahertz transducer and you're scanning abdominal aorta, what is the period? What is the time for one cycle to happen? What do you think? Is it 0.2 microsecond? Is it 5 microsecond? Is it 10 microsecond? Is it 0.5 microsecond? Is it 25 microsecond? What do you think? Yes, exactly. You're going to use the formula. So the formula for that time T, if you remember, T is equal to, or period is equal to 1 divided by frequency. So 1 divided by frequency is 1 divided by 5. And 1 divided by 5 is, I believe that will be 0.2. Why microsecond? Because the unit of the frequency was megahertz. So that's why it will be microsecond. Okay. So I think this much is enough for today. And I hope you will practice this and keep in mind that simple questions can be in the ARDMS. We did a lot of calculation in these questions, but also there can be a question which is they may ask you for the relationship of the formulas. So please try your best. And I hope, I believe actually, if you pay attention, if you focus, you will pass your SPI Registry exam from ARDMS on the first attempt. Take care, and I hope see you for the next session again. Thanks a lot.